we are going to find with respect to the graph, we are going to predict with respect to conductance what will be the concentration. In our question they are giving acetic acid. They are giving acetic acid. We may already aware about that acetic acid is a weak electrolyte. Acetic acid is a weak electrolyte. So with respect to conductance, so I am going to take conductance in the y-axis and concentration in x-axis. In the given graph, we have several graphs, it will be there. We are going to identify which graph is the correct graph for our consideration of acetic acid. So I am going to take different concentrations. For example, this is a 0.1 concentration, this is 1.0, this is 2.0, this is 3.0. For example, the concentration is keep on increases. If we move from left to right, the concentration is increases. Similarly, the conductance, it will be increases or decreases. In our graph, this is least conductance, that is, this is concentration is very low. Concentration is low in this area. Here it is high concentration. So with respect to the concentration, what will be the conductance? Here from the given graph, suppose if I am going to take here, when I am going to keep on increases the concentration, this it will be keep on decreases. So I will draw the graph like this. The concentration, it will be keep on, the concentration is keep on increases, the conductance is increases. These are all the various points of concentrations. So at infinite dilution, that is near the point of 0, infinite dilution, we have maximum concentration, we have maximum conductance. This is due to three factors. One is size of the ion. The conductance, it will be depend of three things. One is size of the ion. Second one is mobility of the ion. Third one is concentration. At infinite dilution, the ions are completely ionized. Ions are molecules. That means, for example, if you are going to take weak electrolyte like acetic acid CH3COOH, this it will be ionized in the manner of CH3COO minus and H plus. So at infinite dilution, there is large ionized state. Hence, we have maximum conductance at minimum dilution. This is maximum concentration, we have minimum conductance. This is the answer for this graph. So we are going to take this graph is the correct answer for this question. We are going to find how many kilogram of aluminum can be prepared with the same amount of current if we passed during electrolysis. If we pass the same amount of current, instead of calcium, in the question they are giving calcium. They are preparing calcium 40 kilogram in a particular time period. They are preparing calcium 40 gram, but they are asking how many aluminum it will be, that is how many aluminum in terms of kilogram, how many aluminum they can prepare with the same amount of current if passed. How to calculate? What is the quantity of aluminum? What is the quantity of aluminum in terms of kilogram? How much kilogram of aluminum can be prepared? Solution for this question: weight of calcium divided by weight of aluminium, which is equal to equivalent weight of calcium divided with equivalent weight of aluminium. This is the basic formula to calculate how much quantity of aluminium can be prepared. In the given problem, we may aware about that I just substituted weight of calcium equal to 40. We don't know how much quantity of aluminium we are going to prepare, that we are going to find out. So I just substitute as such, which is equal to equivalent weight of calcium. What is equivalent weight? Equivalent weight can be calculated molecular mass divided by valency. So for calcium, the molecular mass of calcium equal to 40 and the valency is 2 because Ca2 plus. This is the valency of calcium. So we will get 20. So I just substituted 20 divided by similar manner that we are going to calculate aluminium. What is the equivalent weight of aluminium? Aluminium molecular mass is 27 and the valency is 3 because Al3 plus. So if we substitute these things, we will get 9. So I just write 20 divided by 9. Therefore, the answer is 18 kilogram. Now we are going to find what is the conductivity of a given problem. In the problem, they are giving specific conductivity. The value is 0.011 and molarity or concentration they are given, this is 0.05. So by using this given data, we are going to try to find out what is the conductivity. What is the conductivity of the given problem? We are going to find out delta M. The formula to find out the conductivity is, solution for this problem is delta M. This is the formula, delta M equal to K into 1000 divided by concentration. So now I am going to substitute the values as such. They are giving the specific conductivity value. So 0.011 into 1000 divided by 0.05. Problem is 220 Siemens centimeter square mole inverse.
A current I is flowing in an equilateral triangle of side A as shown in figure. The magnetic field at the centroid will be. So before going into the solution, let us discuss something about the mathematics behind the equilateral triangle and its centroid. So basically, equilateral triangle is a triangle which has all three sides equal. Let us consider a triangle P, Q and R, and these lengths are said to be A, and this is also A, and this is also A. So for an equilateral triangle, PQ is equal to QR, which is equal to RP, which is equal to A. And centroid is nothing but the median of all the three sides meeting at a point. This is said to be centroid. So let us consider this as O. And in our problem, they are given as this distance is A by 2. So we need to find the magnetic field at this point, at the centroid of the triangle, of the equilateral triangle. And one more thing is, equilateral triangle, the angle of all these three vertices are 60 degree. That is, all the three are 60 degree. So let us find the magnetic field for this triangle, for triangle QOR. So if I consider this triangle, Q, R and O, and this is said to be A by 2, and the length between Q and R is A, and the distance between the O and this arm, QR arm, is R. Let us consider like this. So in this case, let us split this into one right angle triangle, and before that this is 60 degree, so half of this will be 30 degree. So if this is 30, here this degree will be 60 and this will be 60, and I am just considering this as theta 1 and theta 2. So my theta 1 is also 60 degree and theta 2 is also 60 degree. So, and now let us consider triangle O, Q and Y. This is a right angle triangle. Q, Y and O, and this distance is R, and you have angle here, that is 60 degree. So here it is right angle, so this side is said to be hypotenuse, and opposite to the degree is opposite side, which is given as A by 2, and the other side is adjacent side, that is given as R. So now let us write for cot theta. Cot theta is equal to adjacent by opposite. So adjacent, you have, this is the adjacent side, so R by A by 2. So when I take it for R, R is equal to A by 2 cot theta, and theta here is 60 degree. So let us substitute this value A by 2 into 1 by root 3. Cos 60 degree is 1 by root 3. So R is equal to 1 by 2 root 3. So now let us consider magnetic field at this point from the arm QR. So for that I can write it as due to on O. So this I am just taking it as B1. So B1 is equal to nu naught I divided by 4 pi R into sin theta 1 plus sin theta 2. As we know that sin, this is theta 1 and this is theta 2. Theta 1 is equal to 60 degree and theta 2 is also 60 degree. So B1 is equal to nu naught I divided by 4 pi R sin 60 plus sin 60 degree. So then if I consider all the three, that is the resultant magnetic field, let us take it as capital B, that is nothing but thrice of B1. So substitute B1 in this equation. B is equal to 3 into nu naught I by 4 pi R. R is nothing but, we know the value, R is equal to A by 2 root 3. So let us write this. So A divided by 2 root 3 into sin 60 degree is root 3 by 2 plus root 3 by 2 is equal to 3 mu naught I divided by 4 pi A, and if I take LCM for this, I'll get 2 root 3 by 2 into this root 3 will go above, so 2 root 3, and this 2 and this 2 will get cancelled, and this 4 and 2 will go, so I'll be left out with 3 mu naught I. Root 3 into root 3 is nothing but 3, so into 3 divided by 2 pi a, or else B is equal to 9 nu naught I divided by 2 pi a. If m be the mass of the charged particle which enters with velocity v normal to the magnetic field B, it will revolve with angular speed given by. So now let us consider a charged particle Q which has mass m and that enters in a magnetic field which is perpendicular to the velocity v, and this be the particle with mass m and charge q. So this magnetic field will exert a force on this particle Fm. So if this force exerts on the particle, so it will take a circular path. So usually when there is a circular path, the radius will be r and the force is said to be centripetal force. And here we have magnetic force. So when we equate these two, we'll get Fc is equal to mv square by r and Fm is equal to q naught v b sin theta. So now let us equate these two. mv square by r is equal to q naught v b sin theta. So we need to find the velocity. So v is equal to q naught b sin theta divided by m into r. Here the radius is said to be 1. So v is equal to q naught b, and theta is 90 degrees since it is in normal. So theta is 90 degrees. So sin 90 is nothing but 1. So the angular speed will be q naught b by m, and this is r. After 2 hours, 1/16th of the initial amount of a certain radioactive isotope remains undecayed. The half-life of the isotopes is radioactive decay. We know that minus dN by dt is equal to or proportional to n minus dN by dt, which is equal to lambda n, or minus dN by n is equal to lambda dt. So when I integrate this, I'll get n by n naught is equal to e power minus lambda t. N by n naught is nothing but 1 by 2 power n. This n is nothing but number of half-lives. So in the question they have given us n by n naught is equal to 1/16. So if I write in terms of 2 power n, it will be 1 by 2 power 4. So there are 4 half-lives. So n is equal to 4, and it is said to be, so 2 hour divided by 4 will give me half hour, or it is said to be 30 minutes.